The old idea to have a settlement on Mars has gained new energy in recent years. This is likely a result of the advancement in technologies capable of taking us there. This year, half a century will separate us from the initial moon landing. It's time to establish a settlement on Mars. The purpose for this settlement should be the primary consideration. In the long term, this Martian settlement will act as an insurance policy against humanity's extinction. The settlement will be expanded to provide a sufficient genetic pool so that, should another global catastrophic event happen on Earth, humanity does not end with it. There is also valuable knowledge to be gained from space. The 6-month journey to Mars is a time in which experiments can be performed in the microgravity conditions of space, providing endless possibilities such as curing cancer. The potential for new discoveries urges us to travel to Mars.
Several engineering challenges separate us from a settlement on Mars. The atmosphere, which is roughly 100 times thinner than Earth's and composed mainly of carbon dioxide, is no exception. To overcome this, settlers would live in pressurized compartments. Using vegetation to provide the oxygen to these compartments would be impractical. Cyanobacteria, however, have been demonstrated to produce oxygen at a rate double that of trees. Water, another essential component for survival on Mars, can be supplied more directly. Trace amounts of water are in the atmosphere, but this again is an impractical source. A permanent setup would likely entail the extraction and purification of water from the regolith, similar to methods performed every day on Earth. The International Space Station is consistently resupplied with food from Earth. This arrangement works for the station, but would not be effective for a Martian settlement. Instead, the regolith must be conditioned so that vegetation can utilize the nutrients. One method of doing this would be to introduce less demanding plants to the regolith. These plants would then die, decompose, and create a soil suitable for the growth of substantial crops. Another option would be to again use cyanobacteria, which is capable of doing the same task.
The health and well-being of astronauts are crucial, so numerous safety requirements must be met. The Martian magnetosphere does not provide adequate protection against the sun's radiation. Prior to human arrival, autonomous 3D printers will construct a protective dome made from the Martian regolith. Then, pressurized models will be inflated upon the astronauts' arrival. These compartments could be relatively large. One academic even suggests having a tree in the great room of the facility for emotional purposes. Another danger is presented by the microgravity effects on the immune system during the 6-month journey. There is no one large gravitational force acting on the astronauts, but many smaller forces in all directions. Thus, the magnitude and specific nature of the suppression on the immune system is unknown. A possible solution to this would be to implement artificial gravity during the trip. Simply put, the space shuttle would split into 2 sections connected by a wire and then rotate.
We won't necessarily know how much this will cost until we do it. Regardless, one source estimates the first stage will cost $20 to $25 billion. This is a considerable amount, and many may advise putting it towards another project. Addressing costs, SpaceX intends to apply the concept of reusability. Currently, the Falcon 9 costs roughly $54 million, which is comparable to that of an airliner. A person can travel by plane for $100 because of the reusability of an aircraft. Having the ability to make thousands of trips over its lifetime reduces the cost tremendously. SpaceX has been making tremendous advancements in technology, including a successful vertical landing, showing that the reusability technology is already here. This makes the long-term cost of settlement on Mars to be remarkably reduced.
In conclusion, a human settlement should be established on Mars. Still, in developing the technologies capable of making this happen, safety should not be sacrificed for an ambitious timeline. This video has shown how we can meet the demands of the situation. It's time humanity becomes an interplanetary species.